So this is the 2016 Leave Insert Higher Level Paper 1, and we're looking at question number 5. Part A1 says the lengths of the sides of a right angle triangle are given by the expressions x minus 1, 4x and 5x minus 9 as shown in the diagram. Find the value of x. Okay, well we know that this is a right angle triangle, so we can use Pythagoras here. If we call this side A, this side B, and this side C. Pythagoras says that a squared plus b squared is equal to c squared. So we're going to set this up. A squared, that's x minus 1 squared, the whole thing squared, that's important. Make sure it's in brackets. Plus 4x, again the whole thing in brackets squared, is equal to c squared, which is 5x minus 9 all squared. Okay, so x minus 1 squared, well that's x minus 1 by itself, plus 4x by itself, and finally 5x minus 9 by itself. So it's a good idea to take your time with this and don't try and rush it. So x by x gives me x squared. I'm going to multiply these brackets out now. Minus 1 by x is minus 1x. X by minus 1 is another minus 1x. Finally, minus 1 by minus 1 is positive 1. Okay, so next I have 4x by 4x, which is 16x squared, equal to, on the other side, 5x by 5x, it's 25x squared. Minus 9 by 5x is minus 45x. And minus 9 by the other 5x is another minus 45x. And then minus 9 by minus 9, which is positive 81. Okay, so now we're going to bring all of this stuff here over to the other side. That's going to leave me with 0 here, equal to, this x squared is 1x squared effectively, so I have 1x squared and 1x squared and 16x squared, that's 17x squared, but when I bring it over it's going to be negative 17x squared. Minus 1x, that's minus 2x, but when I bring it over it's going to be positive 2x. And then positive 1, when I bring that over, is going to be negative 1. So I'm going to have 25x squared minus 17x squared giving me 8x squared. Minus 45 minus 45x is minus 90x, plus 2 is minus 88x. And then I have 81 minus 1, which is 80. So I can now divide everything by 8, so that's going to give me x squared minus 11x plus 10, and again it's all equal to 0. Alright, so I'm trying to find the value of x. So now I can either use quadratic formula now, or I can just try and factorize. So I think there's going to be factors here. The factors of 10, which when added or subtracted give you minus 11, are minus 1 and minus 10. So that means if x minus 1 by x minus 10 is 0, well, if a bracket by a bracket is 0, then one of the brackets must be equal to 0. So we set both of them up. Let each bracket equal to 0. If x minus 1 was 0, that means x would be 1. So that's one possible answer. And if x minus 10 was 0, x would be 10. That's another possible answer. Okay, so the only thing then remains to do is to see if these answers are realistic. Now, if x was 1, well then the side A would be 1 minus 1, which would be 0. So we can't have that. So we can disregard this answer here, because it just won't work in terms of the question. So our answer is x equals 10. Okay, part 2 says verify with this value of x that the lengths of the sides of the triangle above form a Pythagorean triple. Okay, so let's have a look. The triangle was x minus 1, so remember our x value is 10. So 10 minus 1, that's 9. Over here we have 4 tens, which is 40. And over here we have 5 tens, which is 50 minus 9, which is 41. So 9, 40, 41. We're going to see if that's a Pythagorean triple. 9, 40, and 41. Is this a Pythagorean triple? That's what we're trying to verify. So let's see, 9 squared plus 40 squared, is that equal to 41 squared? Well, 9 squared is 81, plus 40 squared is 1600, and 41 squared, you can do this on your calculator, is 1681. And we can see on the left, 81 plus 1600 is 1681, which is obviously equal to 1681. So there we go, we verified the values and they do form a Pythagorean triple. That's 3 numbers, Pythagorean triple, 3 numbers that obey the theorem of Pythagoras. Okay, part B1 says show that the function f of x equals 3x minus 2, where x is an element of the set of real numbers, is an injective function. So an injective function is a one-to-one function. Okay, so if there's a few ways you can do this, but the easiest way is if you can draw a sketch of this function. So f of x equals 3x minus 2, we should know that it's linear and it's already in the form y equals mx plus c. So we can see here that the plus c is minus 2, so it's going to cross minus 2, and it's going to have a slope of 3, so it's going to be something like that. It's going to be going up like that roughly. So it's going to be a straight line, and what we can do is to check if a function's one-to-one rather, we can do something called the horizontal line test. So the horizontal line test involves drawing a horizontal line like this, and if you drag that horizontal line up and down like this, does it ever cross 2 points on the function at the same time? And you can see that it doesn't. If you're dragging this up and down, it's only ever crossing the function f of x at 1 point. So that means it's a injective function. So you can just write down that it passes the horizontal line test. Okay. Finally, part 2. Given that f of x is equal to 3x minus 2, where x is an element of the set of real numbers, find a formula for f to the minus 1, which is the inverse function of f, and show your work. Okay. Well, one way you can do this is change this f of x to a y. So y is equal to 3x minus 2. And you're just going to rearrange this to make x the subject to find the inverse. So bring this minus 2 over here. It's going to become a positive 2. So you're going to have 2 plus y on the left is equal to 3x. But you just want x, so you're now going to divide by 3, both sides. Here the 3's cancel, and so you're left with x is equal to 2 plus y over 3. And so now all you say is that the inverse function is equal to, you now replace that y back with an x, and that's the inverse function, 2 plus x over 3. Sorry, that's f to the minus 1 of x. And that's the inverse function, and that's the end of the question.